Today we're going to be working on implicit differentiation. So we'll start with a few examples of implicit functions, then we'll do differentiation, and then I'm going to give you programs that to work on, our usual, more or less usual procedures. So we'll start with implicit functions. I guess I'll start with our regular functions. Y equals x squared, or y equals sine of x plus x squared, y equals e to 3x plus 1. All those are examples of explicit functions because we have an explicit formula for y in terms of x. And we have y, you know how easy to find what's the connection between y and x. Plug in x, number for x, 2 squared is 4, so y is 2. Do the same thing. Implicit functions. That's slightly different. So there is no explicit formula for y. It's implied that there is a connection between x and y, but there is no exact formula. For example, when we write down the equation of the circle, x squared plus y squared equals 25. We know it's an equation of circle. And it implies that there is a connection between value of x and y, but we don't have a formula. So let's keep this function. So y depends. So value of y depends on value of x. But again, it's implied somehow implicit. And of course we can write down in the word e to x, y equals x plus y. Or x squared, x cubed, y cubed, 7y, 7 y. So you can basically write down an expression in terms of x and y, equality, and that's your implicit function. Explicit function is when you say y equals expression term. Implicit function is connection between x and y. So somehow we still have connection between y and x. So somehow still y is a function on x. Somehow. So because when x plus 1, we want to know what will be its derivative. Good. Still want to find 1 dy. We still want to find 1. Still want to find y prime if a function given to us. So let's see how we're going to do it. So before we go there, let's do a couple of examples on how we take derivatives. Derivative x squared is right. Derivative, for example, 3x plus 1 squared is 2 times 3x plus 1 times 3, right? Times usually chain rule times 3 because it's 3 is that function. So in general, derivative of f of x squared is 2 times f of x f prime. So that's good. Makes sense. That's down channel. Then derivative of y squared. And here y is a function of x. Y is a function of x. And derivative of y squared is going to be to treat y the same way as function x. So it's going to be 2y times derivative inside function y. Does that make sense? So if that makes sense, then derivative sine of y is going to be cosine y times y prime. Okay. Aware of that? So now let's do an example. So let's consider again our circle x squared plus y squared equals 25. And let's find what derivative? So derivative x squared is 2x. So what we'll do, we'll take derivative of both sides. Derivative of 25 and derivative of x squared. Derivative of x squared is 25, 2x. Derivative of y squared is 2y, y prime. Derivative of 25 is 0. So we get 2x plus 2y, y prime equals to 0. And we can continue this now. Because we need to find y prime, dy dx, we want to solve it for y prime. So let me rewrite it. That's 2x plus 2y, y prime equals 0. Now we're going to solve it for y prime, so subtract 2x from both sides, divide by 2y, so okay, negative 2x, 2y, and of course simplify, so y prime equals negative x. So that's how we're going to be finding the derivatives of implicit functions. Our step is going to be to start with our implicit function, and then we're going to take the derivative of both sides. For expression involving y, don't forget that y is a function, so don't forget the chain rule, so where extra y prime will pop up somewhere. So then you're going to get expression in terms of x and y's and y prime, solve it for y prime using the algebra, and that's what we're going to find. Derivative is going to be find it. And derivative is going to be in terms of x and y, so it's a bit unusual because the side of the derivative you have y itself, because implicit function is standard. So let me ask you to do the following program. Find y prime of x cubed plus y cubed equals 7. The solution will work. So taking the derivative of both sides, the derivative of x cubed is 3x squared, the derivative of y cubed is 3y squared, because there's a function on x of y prime, using the chain rule, and equals to 0. So we get 3y squared y prime equals to negative 3x squared. So eventually y prime is going to be negative 3x squared over 3y squared. Y prime is negative x squared. So let's build on that a little bit more, and let's run an example which are more complicated, which will require a little bit maybe product rule, quotient rule, maybe something else. Any questions so far? Again, we're looking for dy dx for y prime. Say we have expression which looks like sine of x y equals y. So the strategy is still the same. We're going to take the derivative of both sides. We're going to solve for y prime. The idea is still the same. Calculation is going to be a little bit harder in this case. Sine of x, y. So we're going to be doing chain rule followed by product rule, or derivative inside. Derivative of sine is cosine. The derivative inside is going to be derivative plus derivative of x is 1, y plus x, y prime. Because derivative of y is y prime. Is possible? right side also chain rule. So going down, x plus y, and derivative inside is 1 plus y. So what we want to do now is we want to solve for y prime, but it will involve a little bit more than just solving it, because if you look at this expression, it has kind of both pieces, with a y prime and without y prime. So we'll have to break it into smaller. So we're going to add to distribute cosine of x, y. So we're going to get y cosine of x, y, plus x, y prime, cosine of x. Because now we can separate terms with y prime and terms with y prime. We'll do the same on the right side. So we're going to get 2x plus y plus 2x plus y, y. So what I want to do is I want to distribute terms with and without y prime. I want to have them separately. I don't want to have a mixture. And now I clearly have terms with y prime and without y prime. See that? So I'm going to put on the different sides. For example, I will keep term with y prime on the left side. So x, y prime, sine of x, y. I want to move it to the other side, so I'll have to subtract it from both sides. Minus 2x plus y prime equals. That guy without y prime, so it has to be moved to the other side, so minus y cosine x, y. And these guys should be kept on the same side. Now I separate the terms with and without y prime with different sides. I factor y prime out. Find its coefficient, find what is on the other side, and then I'm going to take that and find what y prime is. X cosine of x, y plus 2x plus y, plus I guess minus. Copy the right side. Y prime is going to be the right side divided by its coefficient. Something like this. In this case, derivative following example. Again, find new ideas and do the derivative. X, y plus x, 3x squared plus y cubed minus 7y. Go ahead and solve it for y prime. Take the derivative of both sides, find what y prime. Alright, so let me try to put the solution on board and see if you agree with me or not. Derivative of x, y, derivative of x, y, we have to do product rule, so don't forget we still have to follow the rules. So y plus x, y prime. So don't forget the derivative of y is y prime. It's kind of easy to forget. So like 1 times y prime. Plus 6x plus 3y squared y prime minus 7y prime. That's it. Now we clearly see terms with derivative and divide. So we're going to put them on different sides. X, y prime, 3y squared, y prime minus 7y prime equals. I'm keeping the term derivative on the left side and term divided on the other side, so I will have to subtract y, I will have to subtract 6x. So I can factor y prime out. So that x plus 3y squared minus 7 equals y minus 6x. And then I find y prime by dividing by its coefficient. Negative y minus 6x over x plus 3y squared minus 7. Okay, did I do a mistake somewhere? That's what we do if we need to find derivatives. Of course, again, don't forget to follow the rules and don't forget to do your product portion or whatever. Find the slope intercept. One over x plus 1 over y plus 1 is 1 at the point 1. So remember our steps to find this equation of a tangent function. We need to find the slope, and to find the slope we take derivative and plug in per given point. So we're going to find the derivative and plug in the given point to find its slope. So derivative. So we'll do the same thing as we just did a second ago. Derivative left equals derivative right. Not sure how you're going to do this one. You can do quotient rule or you can do chain rule, if x plus 1 to the negative 1. Same deal to this guy. So derivative 1 is for this. So no matter what you do, you either do quotient rule or you do chain rule, you should get negative 1 over x plus 1. Is that that's all? You're going to get something similar when you take derivative 1 over y plus 1. The only difference is going to be because y is a function, so we're going to end up here. So go ahead, you actually going to do it. Y plus 1 squared, and then find negative y prime. Do I need to fill up the details? Caps? Very good. Very good. Then at this point, because we don't need to find y prime, we need to find the slope of tangent. So what we do at this point, I'm going to plug in the point. I'm going to plug in 1 for x, 1 for y. Because our point is 1 and 1. And as soon as I do that, my y prime becomes slope of tangent. The calculation will be quicker. Instead of working with, general expression or like this, I will switch to an expression which involves numbers, which is pretty easy to work. So if I do that, I'm going to get negative 1 over 1 plus 1 is 2, 2 squared is 4, negative 1 quarter, plus negative slope of tangent over 1 plus 1 is 2, 2 squared is 4 equals 0. So, and that expression is not difficult to solve for slope of tangent. Slope of tangent multiply by 4, so that for slope of tangent is positive. I want to say negative, is that so? Now slope of tangent. You recall a point 1, 1. Should be able to find equation that in the slope intercept negative x plus negative x. Equation of the tangent. I guess an equation of the tangent. 2x squared minus xy plus y squared equals 18 and 3 and minus 2. I'm going to give you a couple minutes to work on it. So derivative of x squared is easy, it's 2x. Derivative x, y, don't forget to do product rule, so it's going to be y plus x, y prime. Derivative y squared is 2y prime. Equals to 0, equal to derivative of 19 is 0. Now we're going to plug in x equals to 3, y equals to negative 2, and y prime becomes slope of tangent. So that's good. So we go to the 2 times 3 is 6, minus y is negative 2, x is 3, plus 2, negative 2, slope of tangent. Distribute minus, so 6 plus 2 minus 3 slope of tangent minus 4 slope of tangent equals to 0. 6 plus 2 is 8 minus 8 slope of tangent equals to 0. So if I'm correct, here slope of tangent equals to 8 over 7. So slope of tangent is 8 over 7. You recall the point 3 minus 2. Equals point. To be able to come up with equation of the tangent line. Here I didn't specifically say in which way. Usually I prefer to have a slope intercept form, but because I didn't say which way, it will be up to you. But if I do the slope intercept, it's going to be 8 over 7 x plus, what will it be? If I finish calculations. 7. Sounds reasonable? So that is about implicit differentiation.